In this video, I'm going to explain problems on instruction set, which is the model number 5. It's very important. Sometimes they will ask easy problems. So if you don't know, you're going to make a mistake. So please go through some of the problems I'm going to explain in this video. So let me take the first question. If register R0 is equal to 0x00000 and register R1 is having data 0x80000004. So this is sample data present in R0 and R1 register. The question is find the content of registers R0 and R1 after the following instructions are executed in isolation. That means you have to consider only one instruction is executed. So after that instruction, what is the value of R0 and R1 you have to specify. And you also have to specify the mention if the CPSR means current program status register, whether it is updated or not. So CPSR is current program status register, which has flags. Okay, so you have to specify whether the flags are updated or not. So I will show you which are the flags are there. Okay, this is a current program status register. Okay, ARM core uses CPSR to monitor and control the internal operation. So CPSR is current program status register, is a dedicated 32-bit register and resides in register file. So this is the layout of current program status register. This will ask in the theory also. So out of 32 bits, okay, bit number 28 is overflow, 29 is carry, 30 is zero flag, 31 is negative flag. Okay, these are the flags. This is status, extension, and control. So the interrupt mask bits are IF, T is a thumb state, and these 0 to 4th bit indicates the mode of operation. Let me go to first question now. Move R0, R1. What is the syntax? Move instruction syntax is move. This is the destination. R1 is the source here. First here, suppose if I write move R1, R2. So from this is the source and it will transfer to destination here. After move, whatever register will come, that is the destination. This is source. So instruction is move R0, R1. So that means copy the content of R1 into R0. Okay, R1 will be same only. You have to just copy or move the content of R1 to R0. So in see the register they are given. If R0 is equal to 0, R1 is equal to 8004. So they are already given the value of R0 and R1 before execution. That means pre. PRE means pre and the before. Post means after. Okay, in the before, these are the contents of registers. So now you have to mention the value of, or you have to specify the content of register R0 and R1 after the execution of instruction executed in isolation. That means only one instruction is executed. After this instruction, what are the content you have to specify. So move R0, R1 means copy the content of R1 to R0. So in R1 we have 80000004. So that will be moved to R0. So you have to write the answer as after this instruction is executed. So R0 will have this copy of R1. R1 is 80x, x means hexadecimal, 80000004. That will be stored in R0. So this is the answer for the first instruction. And R1, after moving, we are just copying the content of R1 to R0 also. So R1 is also having the same value, original value of R1. So what is the instruction is move R0, R1 means just move the content of R1 register into R0 also. R1 will have the original value. Same value will be copied to R0. R0 is the destination. R1 is the source. So source content is transferred to the destination, but source also will retain its value. And in this, just it's a move instruction. So current program status register, 4 flags are there. No? These flags are actually not updated. That means no instructions are going to get affected. Okay. If any arithmetic instruction results in carry, overflow, negative and all, then the flags are going to get affected. So in this instructions, it is just a move instruction. So current program status register is not going to get update. Let us go to the second instruction, which is move R0, R1, LSL hash 1. This instruction actually it is again move only. Actually here extra we added they added LSL hash 1. So move is nothing but this is the source register is R1. From R1 it is actually copying to R0. Okay, moving the content of R1 to R0. It is same as previous one, but while transferring, don't simply transfer. So before only we have to do something. What is that? Logically shift left side by how many times? By 1 times. So let me show you the barrel shifter actually. Let me show you that. It is there in the, you can see this. If you are doing some move operation, there is a barrel shifter. Okay. So you can simply copy from source register to destination, or you can also do while transferring only, it will do the pre-processing. So it will actually pass through the barrel shifter and you can move, you can shift the data while coming to the arithmetic only, or while before going to the destination. One data will come directly, another there is an option pass through the barrel shifter. So now actually we are making use of this. So here, okay, move R1 content to R0. So move R0 comma R1 means R1 is the source. From the source, before going to the destination R0, logically shift left side by 1 time. So take the value of, what is the value of R1? So in the R1 we have in that given 0x80000004. So that you have to write this hexadecimal because X is written here. This is hexadecimal. So write in binary because you have to shift logically shift bitwise now. So better you should write in binary form. So 8 means 1000. So you have to write 8 in binary, 800 1000 0 4 be zeros for 0 again 4 zeros. Last one is 4 means 0100. So we have written the same hexadecimal value in binary. Okay. So now we have to shift by how many times they are given? 1 time. Logically shift left side. Logically shift left side means so zeros will be appended here. Okay. So here extra zeros will be appended. This zero, no, this zero is appended here. And whatever is there in the MSB, this MSB will go to the actually carry. But here there is no S in the move. Actually, they are given just MOV. There is no S. So that means don't update the flag. Okay, if S is there, actually save the flag or update the flag. Here there is no S. So move R0, R1 logically shift left side by 1 means. So you have to shift this 32-bit value, write in binary. Okay, this hexadecimal values you write in binary, logically shift left side by 1 time. So this one will go to carry here actually, but it is not updated. So and this will come, this 0 will come to here, this 0 will come to here, this 0 will go to left side like this, and all are zeros only. So all shift by left side 1, this 1 will come here, this 0 will come here and 0. So here this 0 came to this position, and in LSB new zeros are appended. In logically shift left side, zeros are actually appended in the LSB side. So now this is only 1 time now. So it is only one time. Suppose if they ask 4 or 2 or 3, then how many times here number will come, that many times you have to shift left side. Suppose if it is 2, one more time you have to shift left side, and that answer you have to write. So here they are given logically shift left side by how many times? Only one time. So stop at after one time only. So now this is the answer. So you have to write once again in the hexadecimal. So group this one as 0, 0, 0. 4 zeros means 0, 0. And you have to write x, 0x, 0, 0, 0. And this is next one is 1, 0, 0, 0. So 1, 0, 0 means it is 8. So the answer is, okay, you have to write R0 because move R0 comma R1. So destination is R0, source is R1. This is same as previous instruction, but here we are not doing any pre-processing. So here in the pre-processing, the barrel shifter only logically shift left side, then you move the content of R1 to R0. So after logically shift left side, this one will go off. Okay, this one will go off, and this one more zeros are appended here. So this becomes 0100 becomes 8000. That means if we shift logically left side, the value will be doubled. See, this 4 becomes 8. Okay. So this is R0 is destination is 000008. And once again, R1 will have the original value because we are just moving or just copying the content of R1 to R0. But R1 will have its original value of this. And here current program status register, again it is not updated because there is no S here. Coming to the next instruction, which is move S R0 comma R1 logically shift left side by 1. So there is a S. S indicates that update the flag or save the flag. So next instruction is move not R0 comma R1. So that I will show in the next slide. Okay, let me go to this once again, third. Okay, so same problem only this one. Once again, logically shift left side by how many times? It is logically shift left side by one time. That means zeros are appended. This 0s is appended in the LSB side, and MSB 1 is no, that will go off, and this will actually go to the carry. Okay, this will go to the carry, and this is since it is 1 year. Since it is 1 year, carry flag will be set to 1. MSB will go to the carry. No, actually previous also it will go, but we are not saving the content, so CPSR is not going to update. But in this problem, we are given S also, so this is going to update the flag or save the flag. So carry flag is going to set. So answer once again, same answer. R0 will have 0, 0, 0, 0, 0, 0, 0, 8. So this is answer. But and R1 also having its original value of 80004. But in this case, very important is CPSR, current program status register, is going to get updated. What is the reason? In this case, it is going to update because there is a S, update the flag. Okay, let me go to the fourth problem. Problem, move negative R0 comma R1. That means simply don't copy R1 to R0. Don't copy R0 to R1. You have to move negative value of R1 to R1. That means one's complement. You have to take one's complement of R1 and you have to transfer to R1. So you take R1. R1 is what? 0x. R1 is what? R1 is what? This one. Here only it is there. You can see here R1 is there. You can see here this is the R1. R1 is 1000. So take one's complement. So in one's complement, replace 1 by 0, zeros by 1. So 100 becomes 0111, and this 4 zeros becomes 4111, and again 4 zeros becomes 111, like that. Here 0100 is there, so that becomes 1011. So this is the 32-bit value in binary. So if you write in hexadecimal, so write x here, 0111 is 7, 111 is F, 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 F. 1010 is A, 1011 is B. So answer is 0x, x means hexadecimal, 7 F, 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 B. and that value is actually copied to R0. So it is not simply move R0 comma R1. You have to move negative of R1 to into R0. So R0 is the destination, R1 is the source register. So you have to copy negative value of, that means 1's complement of R1 into R0. So you have to write R1 because you have to specify the content of R0 R1 after each instruction is executed separately. Okay. So in this case R0 will be 1's complement of R1, but R1 will have the original value of this, and this is the 1's complement or negative value of R1 is stored to R0. And in this case, okay, if actually it's not arithmetic operation, so it is just a data transfer now. So CPRS is not going to affect, not updated. So last one is move R0 R1. Logically shift instead of shift left side, now it is shift right side. Very important. In the previous, okay, logically shift left side is there. So instead of shift left side, now we have to shift right side. So now before execution, take once again R1, original value of R1 is given. In the problem only that given. Move R1, 0x 800004. So this is, you write in binary, 8 means 1000, so 00004 means 0100. This is we are written in the binary format. After that, we have to shift logically shift right side. So in this, if you shift logically right side, so zeros are going to append here in the ones position. Zeros came. This one is shifted here. This one is shifted here actually. This one is shifted here, and this 0 will go right side will go off. Okay, this will go off. This 0 is coming here. This 1 is coming here. This 0 is coming here. This 0 is coming here. So we are logically shift right side. Zeros are going to append. We added zeros at the MSB position here actually. It is actually a little bit shifted. So this should be here. So let me, this is actually one space is extra is coming. So I pressed it, I think as on extra space it is shifted. So these zeros are appended here and it should come in the place of 1 here. And after that you have to write the answer. So again, this is in binary format. So 32 bits are there. Group it and write in hexadecimal. So 0100 is 4, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0 is 2. So answer is 400. You have to write what is the content of R0, what is the content of R1, and CPSR content after each instruction. So R0 value is now 400002. Then R1 will have the original value. And observe, right shift by right shifting is divided by 2. Actually 80004 becomes 400002. So shifting right side by 1 is divided by 2. Once again, if you shift right side, it is divided by once again by 2. So right shift by 2 is nothing but divided by 4. Right shift by 1 is divided by 2 one time. If you right shift 2 times, it is divided by 4. If you shift right side by 3 times, it is divided by 8. Similarly, left shift multiply by 2, 2 times left shift multiply by 4, 3 times left shift multiplied by 8. And in this case also, CPR's current program status register is not updated as there is no S in this instruction. If you put S here like here, then current program status register is going to get updated. So you refer next video for other problems.